Namaskar. The topic of discussion in this module is on common mineral groups. It is related to the mineral kingdom. Lithosphere is the solid layer of the planet Earth. It is the rocky segment holding all natural resources, including energy resources, water resources, mineral resources and biotic resources. Everything is existing for human survival on this earth. Earth's economic resources include thousands of minerals belonging to the mineral kingdom. Every segment of the human society uses these mineral resources in one form or the other every day, directly or indirectly. There are many minerals which have industrial importance. They are very widely used in several kinds of industries. The Earth's crust is dominated by 8 abundant chemical elements. They are these following: oxygen 47%, silicon 27%, aluminum 8%, iron 5%, calcium 3.6%, sodium 2.8%, potassium 2.6%, magnesium 2% and all other elements makes up to 1%. Silicon and oxygen are the two abundant elements of the Earth's crust. In addition to these two, the other elements which are present on the Earth's crust are all titanium, hydrogen, phosphorus, barium and strontium. It is to be noted that the metals like copper, lead, zinc, nickel and tin play an important role in our modern technology, but unfortunately these are present only in very small proportions on the Earth's crust. The most abundant minerals in the Earth's crust are mainly the silicates. The non-silicates constitute only less than 10% of the Earth's crust. The most common non-silicates present on the Earth's crust are the carbonates, the oxides and the sulfides. There are also naturally occurring phosphates and salts. Minerals are made up of mainly by these ions and elements. Minerals are naturally occurring inorganic substances. They have unique crystal structures and definite chemical compositions. Every mineral can be identified by several of its physical properties and varieties of chemical analysis. There are nearly 3000 minerals available on the earth. Out of these 3000, about 20 are common minerals, making up to 90% of those present in the Earth's crust. Minerals may be composed of a single element like gold or a combination of elements. Minerals composed of more than one element are bound together by electrical bonding. All minerals formed by more than one element are therefore bound together by positive and negative ions. A crystal structure is an orderly geometric spatial arrangement of atoms in the internal structure of a mineral. The chemistry and crystal structure define together a mineral's characteristics. Most of the minerals are chemical compounds. They are combinations of chemical elements. Some minerals are elements by themselves. Minerals are formed from various processes and source materials. Their growth are controlled by the properties like temperature, pressure or other conditions of the environment. It is necessary in geography to know more about these minerals, their chemical formula, physical and chemical properties, the way in which they are used in different industries, their effect on human bodies, the specifications and their availability. Hence, in this episode, the following aspects of mineral groups are highlighted: mineral groups and native elements, carbonates, nitrates and borates, halides and oxides, phosphates, sulfides and sulfates, and finally the wide variety of silicates. Let us see the first part of mineral groups and native elements. Minerals are classified based on chemical composition and crystal structures. Minerals can be organized mainly according to their chemistry into the following 10 major classes: native elements, carbonates, halides, oxides, phosphates, silicates, sulfates, sulfides, mineraloids and organics. Native elements, as the name implies, are minerals containing individual or combined elements. Elements class contains minerals that are composed of more than one element also. Elements by chemical definition are composed of all the same atoms, whereas substances composed of two or more elements are called as compounds. The metals, their alloys and the non-metals belong to this group. Metal alloys are minerals that are composed of combinations of different metals in one mineral. There are 4 subclasses in this group: native metals, metallic alloys, non-metals and semi-metals. Under the subclass on native metals, the most common elements present in the earth's crust are aluminum, cadmium, chromium, copper, gold, indium, iridium, iron, lead, mercury, nickel, palladium, platinum, rhodium, silver, tellurium, tin, titanium and zinc. Let us see the metallic alloys. These are combinations of metals. Many metals join together to form the metallic alloys or the minerals. Iron and nickel form kamacite. Tennite beta is also another mineral. Tetratennite is another mineral. Copper and zinc form the brass. Tanbayite is a mineral containing copper and zinc. Cupellite is a mineral containing copper and zinc and aluminum. Belendorfite is a mineral containing copper and mercury. Auricuprite is a mineral containing copper and gold. Tetraauricuprite is a mineral containing gold and copper. Hunchunite is a mineral containing gold, silver and lead. Chengdeite is a mineral containing iridium and iron. Eugenite is a mineral containing silver and mercury. Let us see the subclass native non-metals and semi-metals. These are including the following: antimony, arsenic, bismuth, diamond, graphite, selenium, silicon, sulfur and tellurium. Minerals with metallic and non-metallic elements are to be understood. Mostly iron and nickel in combination with non-metals like P, C, Si and N crystallize to form these minerals mainly. The next group belongs to carbonates, nitrates and borates. Carbonates are further classified into 2 major classes as anhydrous carbonates and basic hydrous carbonates. The anhydrous carbonates include 2 further groups as calcite group and aragonite group of minerals. The calcite group includes minerals like calcite, dolomite, anchorite, magnesite, siderite, rhodochrosite, smithsonite and spirocobaltite. The aragonite group of minerals include aragonite, bromlite, strontianite and cerusite. Among these minerals, calcite is an important one. It is composed of calcium carbonate. The name calcite comes from a Greek word meaning lime. Calcite is known in more than 300 forms of crystals. Super white quality of calcite in powder form is used in the manufacture of paint and distemper. Calcite is also used now as an insecticide. It is commonly used in the manufacture of cement, calcium carbide, metal polish and also as a fluxing agent. Then comes the basic and hydrous carbonates. The minerals of this group are malachite and azurite. Nitrates are soluble minerals. These minerals are few in number. Nitrates are similar to carbonates. Niter, specifically KNO3, is also known as saltpeter. Nitrate minerals include sodium nitrate, calcium nitrate, barium nitrate, nitre and nitratine. The normal anhydrous and hydrated nitrates occurring as minerals are soda nitre, nitre, ammonia nitre, nitrobarite, nitrocalcite and nitromagnesite. The natural nitrates are for the most part readily soluble in water. Nitre is one of the few nitrate minerals that is available on the mineral markets. In fact, some solid nitrate crystals will even become liquid by removing the water molecules from the moisture in the air, and that process is called as deliquescence. Borate is a compound of the borate ion with metallic elements. Borate minerals are more complex in their structures than typical carbonates, but because of the scarcity and limited distribution of boron in the earth's crust, borate minerals are very limited in nature. There are only a few borates that can be considered common. There are about 100 different borate minerals existing on the earth's crust. The most common borate minerals are kernite, borax, ulexite, colemanite, boracite, sussexite and hydroboracite. These are very essential minerals used in the commercial industries from borate group. Next comes halides and oxides. The halides are a group of minerals whose principal anions are halogens. The halogens that are found commonly in nature include chlorine, bromine, iodine and fluorine. This group of minerals include anhydrous chlorides, bromides, iodides and fluorides, oxychlorides and oxyfluorides, and hydrous chlorides and hydrous fluorides. The following are the common minerals of anhydrous halides. The anhydrous halides include calomel, which is a horn quicksilver containing mercurous chloride. Halite is the next group, halite group. Halite group includes halite, which is the NaCl, which is nothing but our rock salt, sylvite, which is KCl, sal ammoniac, which is NH4Cl, and williamite, which is NaF. The fluoride group of minerals include fluorite and cryolite. The oxychlorides and oxyfluorides include the minerals like atacamite, which is the hydrated copper oxychlorides. The hydrous chlorides and hydrous fluorides include the minerals like cornellite and prosophyte. Next comes the oxide group. Oxygen is the most abundant element in the earth's crust. It bonds readily with a number of metallic ions to form the oxides. These oxides form important ores for the metal resources. Most of the industrial minerals belong to this group. The important minerals of the oxide group are classified into the following families: oxides of silicon, oxides of semimetals, oxides of metals and intermediate oxides. The oxides of silicon include the quartz group. It includes quartz, tridymite, opal and amethyst. Quartz is a widely known mineral, opal is a gem mineral, amethyst is also a gem variety jewelry type of mineral. The oxides of semimetals include arsenolite, valentinite and tungstite. The oxides of metals and intermediate oxides include the minerals like cuprite and the periclase group of minerals like periclase, manganosite and zincite. The next group is the hematite group, which includes corundum, which is an important economically important mineral, then hematite, which is the ore mineral for iron, and the ilmenite, which is also an important mineral for titanium. The intermediate oxides include varieties of groups of minerals like spinel group, which includes aluminum spinel like spinel, iron spinel which includes magnetite, Jacobsite and franklinite, chromium spinel which includes chromite, and the rutile group includes cassiterite, octahedrite and pyrolusite. These are very essential minerals occurring in nature. The hydrous oxides include diaspore, goethite, manganite, limonite, bauxite, brucite, gibbsite and silomelane. Corundum, which is nothing but aluminum oxide Al2O3, is an important mineral in the industries. Corundum is the second hardest natural mineral known to science. Corundum paper and cloth are used to finish the belts, discs, rolls, sheets and other shapes, which are prepared by giving a suitable coating, generally of sodium silicate. Corundum in small quantities is used in the manufacture of special sparking plugs, muffles, pyrometer tubes, rods, insulators for vacuum tubes of all kinds and crucibles. Bauxite is an important ore mineral of aluminum. It is a mixture of iron and aluminum, and it contains hydroxides and oxides. Bauxites are typically classified according to their intended commercial application as abrasive, cement, chemical, metallurgical and refractory bauxites. The fourth group of families of minerals belong to phosphates, sulfides and sulfates. Phosphorus in the form of phosphate ions binds with positive ions to form the phosphate minerals. Important minerals are xenotime, monazite, apatite, vanadinite, pyromorphite, mimetite, wagnerite, triplite, uraninite and autunite. The sulfates are an important mineral class and include some very interesting and attractive specimens. Although many minerals belong to this class, only barite, gypsum, celestite and anhydrite can be considered common. Barites are used in many commercial applications. Drilling fluids consume 85% of the world's total barites consumption, making them easily the largest market. Barite is used as a commercial source of barium and many of its compounds. Ground barite is used as a filter in the manufacture of linoleum, oilcloth, paper and textile manufacturing, rubber and plastic manufacturing. Gypsum, the sulfate of calcium with 2 molecules of water, is one of the most important industrial minerals in India. Gypsum is chiefly utilized in the manufacture of ammonium sulfate fertilizer, plaster of Paris, distemper and cement. A considerable quantity of gypsum is also used as a manure. It is a good soil conditioner and gives growth of peas, beans and alfalfa. Gypsum and anhydrite can be a good source of sulfur. The sulfides also occur as economically important class of minerals. Most major ores of important metals such as copper, lead and silver are all occurring as sulfide minerals in nature. This family includes minerals of sulfides and sulfosalts, selenites, tellurides, antimonides and arsenides. The standard sulfides are important. Sulfur ions bind with a number of positive ions to form the sulfide minerals. Many of them are important ores for the ions to which they bind. Stibnite, orpiment, realgar, bismuthnite, cobaltite, bornite, chalcopyrite, stannite, chalcocite, covellite, digenite, arsenopyrite, petlandite, margasite, pyrite, pyrrhotite, galena, alabandite, cinnabar, metacinnabar, molybdenite, millerite, polydimite, argyrodite, argentopyrite, Stenbergite, agullerite, argentite, tungstenite, patronite and sphalerite are the important minerals belong to this group. Galena is the primary ore mineral for lead. Galena in its chemically purified form is known as lead sulphide. It is one of the most abundant and most widely distributed sulphide mineral in the earth's crust. In addition to this, there is also a subclass including sulfosalts. The sulfosalts are with the combinations of copper, iron, lead, silver, arsenic, bismuth, antimony and tin. The minerals are chalcostibnite, enargite, emplectite, berthierite, cylindrite, bulwangerite, gratonite, barnonite, aikinite, frankieite, mayargirite, proustite, martildite, polybasite and anthroite minerals. The mineral subclass selenites include copper selenite, lead selenite, silver copper selenite and mercury selenite. The tellurides class include lead telluride, gold telluride, silver telluride, copper gold telluride, nickel telluride, silver gold telluride, copper telluride, gold lead antimony iron telluride and mercury telluride. The notable minerals are sylvanite, melanite, calaverite, empressite and petzite. The antimonites group of minerals include gold antimonite, nickel antimonite and silver antimonite. Aurostibnite is a gold antimonite which is very important in the jewellery market. The arsenites include copper arsenites, nickel arsenites, cobalt arsenites, cobalt nickel arsenites, platinum arsenites and cobalt iron arsenites. The notable minerals are nickeline, safflorite, smaltite and lollingites. The fifth group of mineral family includes the silicates. The silicates are the largest, the most interesting and the most complicated class of minerals by far known to the earth. Approximately 30% of all minerals are silicates, and some geologists estimate that 90% of the earth's crust is made up of silicates. With oxygen and silicon, the two most abundant elements in the earth's crust, the abundance of silicates is no real surprise. The basic chemical unit of silicates is the SiO4 tetrahedron. Silicate tetrahedrons have more complicated structures. They can form as single units, double units, chains, sheets, rings and framework structures. The different ways that the silicate tetrahedrons combine is what makes the silicate class the largest, the most interesting and the most complicated classes of minerals. The silicates are divided into the following subclasses, not by their chemistries but by their atomic structures: nesosilicates, which are single tetrahedrons; sorosilicates, which have double tetrahedrons; ionosilicates, which have got single and double chains; cyclosilicates, which are having ring silicate structures; phyllosilicates, which have got sheet silicates; tectosilicates, which are framework silicates. The nesosilicate minerals include olivine group of minerals containing forsterite and phyllite. Garnet group of minerals include pyrope, almandine, spessartite, grossularite, andradite and uvarovite. Zircon group of minerals including zircon and thorites. Al2SiO5 group including andalusite, kyanite, sillimanite, topaz and staurolite. humite group including chondrodite and humite, and titanite including chloritoids. Kyanite is a very important mineral in this group. It is used for porcelains, high temperature bricks and spark plugs. Topaz is often used in jewelry as a precious stone. The blue topaz is sometimes used instead of sapphire or sapphire. Zircon is known as hyacinth. It was originally a blue gemstone, perhaps the sapphire. The sorosilicates include epidote group including epidote, zoisite and allanite. It also contains vesuvianite. The ionosilicates are single and double chains. The single chain ionosilicates include pyroxene group of minerals with enstatite and ferrosilite, diopside and augite, jadeite, agerine and spodumene. The pyroxenoid group includes wollastonite, rhodonite and pectolites. The double chain ionosilicates include amphibole group. It includes anthophyllite, cummingtonite, tremolite and actinolite, hornblende. It also has sodium amphibole minerals. The cyclosilicates are ring silicates including axinite, beryl, cordierite and dioptase. Tourmaline group of minerals also belong to this. Beryl is the chief ore of beryllium. It is used in transistors. The green form of beryl, emerald, is a precious stone and has been valuable for a long time. Tourmaline makes an attractive gemstone, particularly the crystals which have two colors. The phyllosilicates are seed silicates including serpentine group of minerals. They also include clay group of minerals with kaolinite, illite and montmorillonite, vermiculite and talc, mica group of minerals including biotite, muscovite and phlocopite, then chlorite group of minerals including chlorite. Serpentine is used as a decorative stone. Talc makes the talcum powder. Another name for talc is steatite. It comes from the Greek word suet. This is because the surface feels greasy. It is very easy to carve these stones to make statues. Talc is one of the most important industrial minerals and it is used commonly as talcum powder. We are using it as a body or face powder. Muscovite mica was once used for windows instead of glass pieces. It still is used for iron stove windows. It is also used as an insulator for electrical equipment. Vermiculite mica forms a water absorbent substance used in seed planting and also as an insulating material. The tectosilicates are framework silicates. It includes the minerals of quartz group which contain quartz, tridymite and cristobalite, then feldspar family which include alkali feldspars and plagioclase feldspars, feldspathoid family, zeolite family and scapolite family. Amazonite is a microcline feldspar which is mainly used in the ornamental stones. Asbestos is mainly coming under these categories. Chrysotile asbestos, the fibrous variety of the mineral serpentine, is by far the most important type of asbestos commercially used in the world. The feldspar group comprises minerals containing potassium, sodium, calcium and aluminum silicates. They are the most common rock forming minerals. Graphite is a good conductor of heat and electricity. It has high refractiveness. It can also stand a temperature up to 3000 degrees centigrade in an inert atmosphere, though in the presence of oxygen it burns between 620 degrees centigrade to 720 degrees centigrade. It is unaffected by most of the acids and reagents. Titanium is a metal used mostly in jet engines, aircrafts and space and missile applications. In powdered form, titanium is used as white pigment for paints, paper, plastics, rubber and other materials. There are many minerals which have got industrial applications. They are widely used in different industries. It is necessary to know more about these minerals, their chemical formula, physical and chemical properties, the way they are used in different industries, their effect on human environment and their specifications and availability in geography. Let us see further details in the next module.